Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 2nd March 2023. The problem statement for today is walls coloring 2. Let's now open this problem. Let's understand this problem statement first. Here it is said that there is a row of n walls in Geekland. The king of Geekland ordered Alexa to color all the walls on the occasion of New Year. Alexa can color each wall with one of the K colors. The cost associated with coloring each wall with a particular color is represented by a 2D cost array of size n cross k. For example, cost 00 is the cost for coloring wall 0 with color 0. Cost 12 is the cost of coloring wall 1 with color 2 and so on. Find the minimum cost to color all the walls. You need to fill the minimum cost you need to find the minimum cost to paint all the walls such that no two adjacent walls are the same color. If you try to recall, then this problem is similar to one problem which we have already solved earlier. It was on here, this walls coloring that was asked on 14th of September. So this is similar to that only, but instead here in the problem of walls coloring, only the color limit was fixed to 3 colors. Here it is saying that it can go up to n colors. It can go up to k colors. So that is the difference here. So that would definitely increase some complexity of finding the different alternative way, because there we need to find only among the two of the rest colors, and but here we have to find the minimum of the remaining k colors. So let's understand this problem and this example first. Here it is saying that number of walls is given is 4 and colors is 3. So cost, this is the cost sheet. So here I'll just explain for one row. So this, the first one is for painting the first wall with color with first color. This is for painting second wall with second color and third wall with third color. Here it is not mentioned as red, green or blue, anything, nothing like that. Here it is given with the color number. So let's try to approach to this solution using the same approach which we had seen there in walls coloring question. So for that, I just copied it to here just to explain it the approach the way we had solved. We will try to solve this question with the same approach initially, and if any optimization is required, that time we will look for the solution, different solution. So here if you see, then this is the cost sheet and this is the cost array, 2D array which is given in the problem. So here we can see, if we are trying to create the DP array which we created in walls coloring question, then here it is see that for painting the first wall, so the cost would be 1. For painting the second wall with first color, the cost would be 5. For painting the third wall with third color, for painting the first wall with third color, the cost will be 7. This we have taken with this one only. So first row will indicate the cost of coloring first wall with with k different colors, second wall with k different colors, and so on. So and for painting the second wall, we will take this cost, this is which is 5 here. To this we will add what was the minimum cost from the previous step. Minimum cost from the previous step which is not equivalent to the same color. So if you are taking the minimum of 1, but here we can see this color, this is the color colors number 1. So we cannot paint the second wall even with the same color, because that the same condition is there even in this question, that no two adjacent wall can have same color. So we have to look for the from the rest 2. So minimum of rest 2 is 5. So we have got this 5 here. So similarly, the cost of painting second wall with color 2 is 8 here. Okay, so to this one we will add that what was the cost for painting the first wall. So so from that we see minimum of 1 and 7. Minimum of 1 and 7. So it will give here 1. So it will be 8 plus 1, that is 9 here. Then similarly for the second wall, if you are trying to paint it with the third color, then it will see what is the minimum cost. So it is the 4, it is 4 here, so that cost is coming here. Then we have to see the minimum from the rest two walls. So rest two walls is 1 and these two, sorry, from the rest two colors, painting the first wall from the with the rest two colors. So the minimum cost is 1 here out of 1 and 5. So that we have taken here. So that only, so this way we are formulating this 2D array which is with the name DP. And in the last step we are seeing that for painting n walls, that means here it is n is 4, 1 2 3 4. So painting n walls, what is the minimum cost? So here we can see, if we are following the data approach only, so we can see that 8 is the minimum one. So how we are coming to 8? First we are taking this one. Then in next step we are taking this 4 plus 1, that is 5. Then in next step we are taking minimum of this one, that is 7. So to this we are adding 1 plus 7, that is coming to 8. So in each step we are taking the current value of the color, and to that we are adding the from the previous step, what is the minimum cost to paint the previous wall, the charges incurred to paint the previous wall with the other two colors. So here this problem is this solution approach is similar to what we have solved in walls coloring thing. Here only thing is that here only 3 colors is there, so that's why we are solving it this way. But if k colors are there, then we have to find among the minimum of k colors in the previous step. Here we have directly taken from the 3, so we have directly taken the rest 2 colors, but there it can be any number of colors. So we have to find the minimum from the rest of the colors. So with that approach only, let's solve this problem. So I'll be solving this with the same approach with which we have solved walls coloring problem. So I have already prepared that code. So let's try copying it here. So this is the cost. So this is the solution which we have, which I have already typed just to save the time. So here also, if you see, the same approach has been followed, where at each step we are calculating the colors with looking at the previous minimum. So this is exactly the same approach, only instead of only 3 colors, here we have taken k. So for that we are running through this for loop k, and we are trying to find the minimum from that array. Okay, so here it is again a DP approach of solving this problem. So now let's try compiling this solution. So here we can see we have got this example solution correct. Now let's try to see by submitting the solution. I hope this solution is clear. If whatever I have written here, to solve this problem we have used dynamic programming, where dp of I and j be the minimum cost of painting the wall up to I, and where ith wall is painted with color j, we can calculate dp of ij, and at each step we follow this one. Dp of ij is cost of ij plus minimum from the previous step, while running through the scale loop. And after that is done, then we are finding the minimum value from the last row of dp. So the significance of last row of dp is that in last row only we reach the nth wall. That means we have painted all the walls. So whatever the cost there, we'll just take the minimum cost, and if by chance if that is infinite, which we have initialized initially, then we will return -1, else we'll return the minimum cost. Now let's try submitting this solution. So here we can see out of 1119 test case, 1117 have passed. That means 1118 test case, that this has failed. So we have to optimize the solution. So here one way to optimize the solution is that we can reduce space complexity of this dp table. We only need to keep track of the minimum cost of the painting the walls up to ith walls, which can be done by using two variables, previous min cost and previous second min cost. We do not need to build that complete DP array and just keep on populating that. So we will just use two variables there, the previous minimum cost and previous second minimum cost, and in each time in this subsequent step we will try to find the minimum using these two variables only. So here we can see that again the same approach we will follow. That means the programming way will be same. So I have even got that code ready. So now let me first delete this because this is not that optimized. So this is deleted, and now I'll try to use the code which I have already kept it ready just for saving the time for typing it. I'll explain this code line by line, the optimized solution one. So here this is the solution which I have written using the two variable, that is previous min cost and previous second min cost. So here if we try to go through it line by line, then here what is says, this function takes a 2D array cost as input, which represents the cost of painting each wall with each color. So that is already known. We get the number of walls n and number of colors k from this array. We also define a very large number, infinite, to represent infinity. We then initialize three variables to keep track of minimum, second minimum cost and colors used for previous walls. So this is done here. Then after this we are iterating over each of I and each of color j. Then we initialize those three variables, that is current min cost, current second min cost and current min color, to keep track of minimum and second minimum cost and the color of the current wall. Okay, so if this is the first wall, so this condition there, if this is the first wall, then we update current min cost and current second min cost. And if the cost of painting the current wall with color j is lesser than either of these variables. If this is not the first wall, then we calculate the cost of painting the current wall with color j based on the color used in the previous wall. If the previous wall was painted with a different color, that is j not equal to previous color, this one, if j is not equal to previous min color, then we add previous min cost to the cost of painting the current wall with color j, otherwise we add previous min cost. So this condition I am talking about. Then otherwise we add previous min cost to the cost of painting the current wall with color j. Then we update current min cost and current second min cost if the cost of painting the current wall with color j is less than either of these variables. Then we finally update this previous min cost, previous second min cost and previous min color to the values of current min cost, current second min cost and current min color respectively for those loop. Then after this iteration is done, then over all the walls, then we check if it is possible to paint the walls. If the value of the previous min cost is still infinite, that means we have not been able to replace it with any suitable values, then we can say it is not possible to paint all the walls without painting adjacent walls with the same color, so we return -1. Otherwise we return the value of previous min cost, which represent the minimum cost of painting all the walls without painting adjacent walls with the same color. So this is the optimized solution where we have used only we are keeping track of the previous step value, not the entire DP array. So here we are trying to reduce the space complexity of this one by using only two variables there. I hope this part is clear. So yeah, so now let's try compiling this code with this new solution. So here you can see even this example output is given correctly. So let's try submitting the solution now. See here, this time we can see with this approach of using two variables, that is pre min cost and previous second min cost, we can see that that issue of time limit exceeded, that is not coming in this problem. So all the test cases have been passed. I'll provide the link of this question in the description box as well, and the link for that walls coloring video even in the description box, and the question link as well. So yeah, so this problem has been solved successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.